Number 1 said, write the following in decimal form to at least 4 decimal places, and then identify as rational or irrational. What I really want to know is, can you tell whether it's a rational or an irrational number? So let's see. Number 1, what's the symbol for rational? Do you remember? Q or Q bar. Number 1, I think, ends up being irrational. I don't care what the decimal is. Well, I can tell you it's a bit bigger than 8. It's negative 8.1 something, 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 something. But I know, since it's a square root and it doesn't work out evenly, it's irrational. Number 2, the definition of rational was you could write it as a fraction. Is that written as a fraction? Hey, then it's rational. 11 over 9, is it 1.22222222?
Yep.
Yeah. I know my fractions. Number 3, now this is a square root of the square root. I was going to think maybe it's irrational, but I know the square root of 16 does work out evenly, and I see a 16, although it's 0.00. You know what? I think I'm going to hedge my bets this time, and I am going to evaluate it just to play it safe. So I'm going to go the square root of 0.0016. Oh, I get 0.2. Is that number rational or irrational? Rational. Q. Oh, Mr. Dewick, why'd you put a Q bar over there? I don't know. Q, not Q bar for B. Duh. Caught myself before I had to give away a candy. D. Now, when I look at D, there's definitely a pattern. I see 1.12131415. What do you think comes next? I'm guessing 16171. Ah, but is there the same segment of numbers that's repeating? No, then this does not terminate. It doesn't repeat. It is irrational. Q bar. Number 2 says, check the boxes of the sets that each number, so 1 mark for each of those. Check the boxes of the sets that each number exists in. Yep. Yo.
For 1D, isn't it rational because it goes like 1, 2, 1, 3, 1, 4?
Nope. Is there a repeating set of numbers? No. I hear this. 1, 2, 1, 3, 1, 4, 1. I don't hear the same numbers over and over and over. I see a pattern. But just because there's a pattern, that doesn't mean it's rational. In fact, it's irrational. Okay? They love that one, by the way, on the provincial. That's one of the ones they love to throw at kids. Number 2, check the boxes. They're all real. Okay. -5 is rational. It's an integer. It's not a whole number. It's not a natural number. So the way I'll mark this is half mark off for each box that's missing or extra. So it's out of 1 if you have 2 wrong. So if you're missing 2 boxes, or you have 1 extra twice, or half mark off for each mistake. Root 6 is irrational. So half mark for checking the real, half mark for checking the irrational. The square root of the square root of 81. What's the square root of 81? What's the square root of that? 3? You know what? I can do that in my head. This is actually a 3, which means it's rational, it's an integer, it's whole, and it's a natural. Half mark off for each one of those that you're missing, or each one of those that you checked that you shouldn't have. Pi, irrational. -2 over 3, rational. Is it an integer? It's negative. Ah, no, integers were only whole numbers that were negative. So that question's out of 1, 2, 3, 4, out of 5. Let's see. In each case, determine the number of factors. The number of factors. Well, 8 has 1, 2, 4, and 8. You know what? That's got 4 factors. 17, that one I can do in my head. It's got 2 factors, 1 and 17. Number 4 says, use a tree diagram or a division table to determine the prime factorization. Okay. I went like this. 10, 39. Is 10 prime? Nope. Is 39 prime? Nope. But 10 is 5 times 2, and those are both prime. 39 is 3 times 13. So I said, ha-ha, The prime factorization is 2 times 3 times 5 times 13. That's the answer I'm looking for. Mr. Duick, what if we had them in a different order? If you have a 2, a 3, a 5, and a 13 and nothing else, I'll give you the mark, but you must put a little frowny face next to your answer, because let's put them in order from smallest to biggest, please, so our answers all look the same. Not that hard. 546. Ooh. What goes into 546? I'll try 2, sure. 2, which is prime, and, sorry, what? 273. What goes into 273? 3 does? '91 is a weird one. 91 I thought was prime, but I started guessing. I said, I know 5 doesn't. I tried 3, didn't work. I didn't bother trying 5. I tried 7. Does 7 work? Yeah, that was a little surprise to me. 7 times what? Ah. And those are prime. So the prime factorization is 2 times 3 times 7 times 13. Let's see. This quiz, it says it's out of 19. 1, 2, 3, 4. Did they go 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18? No, they didn't do that. So that's out of 5. So we got out of 4, Mr. Duick. Out of 5, that's 9. You don't have a back page. Maybe I forgot to photocopy a back page. That's 1 out of 10, 11, 12, 13. You know what? This quiz is out of 13, not out of 19. I think. Give yourself a score, please, out of, count 'em, 13, and then pass them inwards. Any questions from the textbook homework that you want me to go over? Pardon me? First I'm asking, are there any questions from the textbook homework that you want me to go over? There's a process to this, my friend. I heard someone say 4 or not? 4? Okay. Number 4, let me get my textbook out, Mr. Duick. Page 206, number 4. Said, what happens when you try taking the square root of a negative? If you try on your calculator going, what happens? You get a math error. Why? The definition of square root, the definition of the answer, Marcus, when I say the square root of 9 is 3, what I'm also saying is that 3 squared is 9. What number squared is negative 4? Well, if I put a positive here, 2 squared is not negative 4. What's 2 squared? Positive 4. So that doesn't work. If I put a negative here, what's negative 2 times negative 2? 4. Is there any number that I can square and end up with a negative? That's why you get a math error. You can't take the square root of a negative number. You can take the cube root of a negative number. You can't take the square root. Does that answer your question? Because that's the answer. Okay. I also gave you assignment number 1. I'm not going to collect this officially today because I haven't made up a full answer key yet. I got one from Mr. Rocca, which I'll put online. But I will start out by saying, hey, on the first page, were any of these that you were looking at going, I have no idea how to get this? So it was 6C. Right, 24 is the product of prime numbers. So that's saying write the prime factorization. Factor tree. I think you get this, don't you? That's it. That's all it wants. Okay? Yep. Why do 0 and 1 have no prime factors? Because we said prime numbers were 2 or larger. 1 and 0 aren't prime. So 1 and 0 don't have any prime factors. You guys got the twin primes one okay? So twin primes are primes that are 2 apart, like 5 and 7. 11 and 13. 17, skip 19. 29, skip 31. Those are called twin primes. Mr. Dewick. Yes, Garrett. Lesson 4, radicals. Psst. Ready? Quick review, what we've done so far. We've been talking about square roots. All positive numbers have 2 square roots, 1 positive, 1 negative. 2 squared is 4. Negative 2 squared is 4. The positive square root is called the principal root. And when I use the square root symbol, I'm asking for the positive answer. That's why when I say to you, hey, what is the square root of 9? Garrett, you don't need to say 3 or negative 3. It's 3. And you're saying, yeah, I know it's negative 1. I know there's a negative answer out there too. Recall the square roots of perfect squares. Those are rational if they work out evenly. Non-perfect squares are irrational. Cube roots. We also talked about higher roots than just square roots. We said you could have cube roots. A cube root, instead of saying, Marcus, something squared equaled your answer, a cube root said, what number, that's supposed to be a 3, let me make that a little better, what number cubed equals your answer? For example, what cubed is 8? 2. The cube root of a perfect cube is rational. Otherwise, if they don't work out evenly, they are irrational. It says evaluate using a calculator. Okay. No, you know what? Let's do these in our head. Square root of 25. We can do that in our head. 5. Square root of 100. Square root of 64. Square root of 225. 15. Square root of 15, this won't work out evenly. It's going to be 3.8, 3.9. What is that one? 3 decimal places. 3 point what?
3.872.
What comes after the 2?
9, so it's 873.
873. Now, by the way, because square root is the most common, if you just say root, we assume you mean square root. We say, you know what? Unless you tell us otherwise, if you say the word root, we'll assume it's square root. So I could read F as root 7, also square root 7, but root 7 sounds nerdier. So Greg, since you're dressed as a nerd, let me hear you say root 7. Woohoo! Sounds like a nerd. Hey, what's the square root of 7? What's root 7? 4 point what? 4.645. 4? Is it? No, it's got to be 3 point something, or 2 point something. 2.646 or 645? So it's 646, 2.646. Oh, cube root of 8. Amber answered that. Cube root of 64. 4. A few more. Cube root of 125. Fourth root of 625. So what we're saying is, what number to the 4th power equals 625. Now, how did we do 4th root? We did play around with that a little bit. Sorry? It is 5, because 5 times 5 times 5 times 5 equals 625. Cube root of negative 64. Oh, wait a minute, Mr. Dewick. I thought you said you couldn't take the square root of a negative. Square root of a negative doesn't work. Does cube root of a negative work? Try it on your calculator. It does. Negative 4 is what your calculator will say. Fifth root of 32. What to the 5th power equals 32? Pardon me? 2. Yeah, it's 2, 4, 6, 8, 32. It's 2 to the 5th. Fifth root of 144. This one won't work out evenly, so let's review how we do this on our calculator. We would go 5th root, so you press a 5. Then we would find our nth root button. Mine looks like this symbol right here. Most of yours does too. 144. See if you can get the 2.702 to appear on your calculator. If you can't, now is your chance to ask. I'll help you. Everybody got that okay? Figured out your calculators? Oh, good. Try n on your own. Cube root of 729. I think this one works out evenly.
Yep.
Is it 9?
Yes.
All right. Radicals. No, radicals. Math. Expressions like root 30, cube root of 125, fourth root of 15, sixth root of a million, etc. We call these radicals. In fact, we call that funky symbol the radical symbol. What do we call a number that looks like this? Begins with the letter F. Okay, fractions. The horizontal bar is a symbol for fraction. That thing is a symbol for a radical. Any expression that looks like this, as long as n is a natural number, what does that mean? The number sitting right there can't be a decimal or negative. Is called a radical. And in fact, we get more specific. We call the symbol the radical sign. We call what's inside the radicand. And we call the number right there the index. So if you're doing a cube root, your index is 3. If you're doing a fourth root, your index is. If you're doing a fifth root, your index is. What if you're doing a square root? Technically, your index is 2, but because it's the most common one, remember how I just said that we don't say square root, we just say root? Traditionally, see, technically, I should put a 2 there to show that it's square root, but we decided a long time ago, you know what, if you leave it blank, assume it's square root because it's the most common. It's like every fraction, technically, every number is technically over 1. Do we write the over 1 all the time? Do I write this? I just write 6. We've clued in over the years. Well, you know, the most common one, let's just forget it. Okay? Oh, and if you have the whole thing, we call the whole thing a radical expression. A radical. Note, when the index is not written, like square root, it's assumed to be 2. So if it's blank, square root. The index is the number of times the radical must be multiplied by itself to equal the radicand, what's inside. In other words, when I write this, Brody, the fourth root of I don't even know if that works. Oops, wrong one. Let me see. 1296. If I write the fourth root of 1296 equals 6, what I'm really saying is that 6 to the fourth is the radicand, which it is. Okay. Tells you how many times we multiplied the answer by itself to get what was inside the square root. Example 2. Turn the page. Identify the index and the radicand in each of the following. What's the index in 2a? 4. What's the radicand? 64. What about in 2b? If it's blank, we assume it's a square root. And the radicand is 85. What we're going to ask ourselves now is, okay, what are the math rules for doing math with radicals? You learn some with fractions. You would never write this. What would you write instead in your final answer? 1/2. You would never write this. what would you write instead in your final answer? 3 over 4. You would reduce, you would simplify. Well, for radicals, there is also a similar rule, a similar procedure. First, we have to look at what's called the multiplication property, and it says this. If I'm multiplying two things together inside a radical, that's the same as taking the root of the first one times the root of the second one. Here's what I really mean. Square root of 4 times the square root of 6 is the square root of 24. Which kind of makes sense. One of the rules for roots is multiply roots by roots. Roots times roots work. Square root of 16 times the square root of 9 is the square root of 16 times, I don't know why that suddenly became a 4, that should be a 9. Okay? And proof. Well, there's two ways to do this. The first way, if we wanted to prove this, what is the square root of 16? What is the square root of 9? So you could do the square roots first. You'd get 4 times 3, which is 12. Or, what is 16? Fix that, make that a 9 as well. What is 16 times 9? Do that first. What is 16 times 9? 144. What is the square root of 144? Also, so what we're saying is root 5 times root 6 is root 30. That's allowed. That's allowed. Oh, and this is also root 3, root 10. Is that not still root 30? Oh, and this is also root 2, root 15. Still root 30. It says write the following as a single radical. What's root 8, root 3? What's root 8 times root 3? Root 24. B. C. D. Root 42. Going backwards, you can also write a radical as the product of two radicals. For example, it says express as the product of two radicals, root 24. I can write this a bunch of ways. I can write this as root 24, root 1, or root 12, root what? 2? Or root 6, root 4, or root 8, root 3. One of those is nicer than all the rest. We'll talk about why in a little bit. Hey, how can I write root 34? (34) is what times what? Sure, root 2, root 17. You can put a times between them if you want. Or root 1, root 34. Anything else? No, 17 is prime, 2 is prime. I don't think there's anything hidden in there. Root 28. Well, I can write that as root 28 times root 1. I can write that as root 14 times root 2. I can write that as root 7 times root 4. One of those is much nicer. Root 44, I can write that as root 44 root 1. I can write that as root 22 root 2. I can write that as root 11 root 4. I think that's it. I like that one, root 6, root 4. I like this one here, root 7, root 4. I like this one here, root 11, root 4. I don't like root 2, root 17. Does anybody see why I wrote a little happy face on those ones? Yeah, why do I like them? What about the 4? Hold that thought. Okay. We have two main types of radicals. Go back to fractions again. We had a number like this. You also had stuff like this. Right? What did you call this number? Began with the letter M. Do you remember? Ooh, nice. Mixed numeral. And then this was just a standard good old fraction. Well, we have the same thing in square roots. We have standard radicals. They're called entire radicals. We have mixed radicals. Why are they mixed? Because some numbers are in the radical sign and some numbers are in front of the radical sign. They're mixed. Okay? And here is the key to today's lesson. So if you're tired and dozy, sit up. The key idea here, Brianna, is we can convert some entire radicals into mixed radicals, and we call this simplifying. It's similar to writing a fraction in lowest terms. So you learned in grade 8 that for fractions, you never told me the answer was that. You would always do that. For square roots, we can do a similar mathematical operation, but it won't be simplifying a fraction. What it will be is simplifying a square root. In order to do this, you need to memorize the perfect squares. I was going to have us list them, but we listed them a couple of days ago, did we not? Yeah. So you need to know the perfect squares. To simplify radicals, you know what? It's easier to do an example first. Then we'll come back and write the rule. So, root 24. What I want to do is I want to write it as something times something, except I want the first something to be a perfect square, to be either 1, 4, 9, 16, 25, 36, 49, 64, any of those. 24 is what times what? Don't say 2 times 12, doesn't help me. What? So root 24 is root 4, root 6. Let's write that down. Why did I pick those? Because of that first number. What is the first number there, Brody? What is it? Read it to me. Root 4? Hey, what is the square root of 4? This is 2 with a root 6 on the end. I have just reduced that 24. I found any hidden perfect squares inside the 24, and Kira, I said, hey, let's do that math and just leave what's not a perfect square behind. B, root 12. Let's simplify that. 12 is what times what? Don't say 2 and 6. Doesn't help me. You know what? Let's decide from now on. We'll always say the perfect square first because you want to write it first. Trust me. So don't say 3 and 4. Don't say 3 and 4. 4, 3. Always the perfect square first. This is root 4, root 3. What does it simplify into? 2 and a root 3. 50 is what times what? Don't say 5 and 10. Those aren't perfect squares. So root 50 is root 25, root 2. How can I simplify that? Alex, what is the square root of 25? 50 is 5 root 2. Let's pause for a second. Get your calculators out. Okay, Mr. Smarty Pants. I'm going to go square root of 50. You know what I get? 7.0710678812. I'm going to go 5 times the square root of 2. You know what I get? Same thing. Which is what we're saying, by the way, because I did put an equal sign here. What we're saying here actually is, you know what? Hey, this is the same as that, but this is the lowest term simplified radical. You pulled out any hidden perfect squares. Okay? Oh, are there any perfect squares left inside? 2 is what times what? Nah. Are there any perfect squares hidden left inside with A? 6 is what times what? I can't get a 4 or a 9. Yeah, good. D, root 72. 9 and 8. So root 9, root 8. So you're telling me it's 3 root 8? And we're wrong. Can we see why we're wrong? We're not done. Yeah, what? What? Where? Oh, 8 is what times what? This is 3 root 4 root 2. Now the nice thing is, by the way, the biggest perfect square, Alex, that goes into 72, I know is 36. And sometimes a kid gets that right away, but if you don't get it, did I just show you how you can kind of hopscotch your way there by just getting in the habit of always checking your radicals for any more perfect squares? Okay? You don't need to know all the big ones. It helps. It's quicker. But you can get away with knowing 1, 4, 9, 25, and a few more than that. What is the square root of 4? So you're saying this is really 3 times 2 times root 2? Except I wouldn't write 3 times 2. Well, what's a nicer way to write 3 times 2? What is that? This whole thing is 6 root 2. Let's go up here and let's write the steps. Rewrite the radical as a, what's the fancy schmancy word for multiplication answer? Begins with letter P. As a product with a perfect square. Okay? So again, even though 24 is 2 times 12, that's a waste of my time. 2 is not a perfect square. 12 is not a perfect square. I'm not even going to try those. It's a waste. What numbers am I going to try? 4, 9, 16, 25. It's a pretty quick list. Then take the square root of any perfect squares, rewrite the rest, and, oh, Alex will repeat if necessary, just in case there was a huge perfect square that we didn't see, like 36. E, 4 root 18. Okay, I think you can already figure out the 4 just stays in front for a little bit, just like that 3 stayed in front for a little bit in the previous one. 18 is what times what? Don't say 6 times 3, it doesn't do me any good. It's root 9, root 2. Ooh, let's see how good we are. What is the square root of 9? What's in front of all that? A 4? So I have a 4 times 3? Yes. What is going to be in the front of everything? Are you telling me this is going to be 12 root 2? Because the root 2 I can't do anything with. You would be correct, sir. F, negative 7 root 24. Let's see. I'm going to drop the negative 7 down. And I'm going to write the 24 as root 4 root 6. By the way, the most common mistake, kids often get to this line, and they're so proud they found the root, they forget to take the square root of the 4. The number of times I'll see kids go negative 7 times 4 and put a 28 in front, that's by far the most common mistake. Don't do that! Don't do that. What is the square root of 4? With a negative 7 in the front? Negative 14 root 6. Right? Not too bad. Let's try a few more. Two root 25. Oh, hey, wait. 25 isn't 25 a perfect square already? Okay. So we only use this method if it's not a perfect square. If it is a perfect square, what is the square root of 25? Just plain old 5 root nothing. This is really 2 times just plain old 5. Not 5 root 5, just 5. Because 25 is a perfect square. Amber, what's the answer? 2 times 5. Yeah. Right? 2 times 5 is 10. Third times. Uh-oh. Happy Halloween. H. Ah! No. Relax. Relax. You know what the first thing I'm going to do is? I'm going to say, well, there's a 2 in front. Why don't I rewrite that? What do you see inside the radical? What do you see in the radicand? Oh, let's deal with the x squared. You know what? Let's separate it. We'll call it root 48 and root x squared. Let's write the 48. 48 is what times what? Don't say 6 times 8. Those aren't perfect squares. Okay. So this is root 4, root 12, root x squared. What? I thought I heard somebody say something or notice something. More specific, otherwise you're just playing golf. Or what number are you looking at right now? Okay, maybe you're not. All right. This is going to be, what's 2 times the square root of 4? What is the square root of 4? Times the 2 in front is? What's the square root of x squared? And what do I have left in the middle here? Root 12? We're wrong. Yeah, write it down, but we're wrong. Anybody see it yet? Really? What, Anthony? 12 can go further. 12 can go further. In fact, 48 is 16 times 3. But if you don't see it, no problem. But you have to get in the habit then, Cindy, of saying, okay, do I have anything else inside the radical that can go? Yeah. 12 is what times what? 4 times 3. So you're saying that this is a 4, an x, a root 4, and a root 3. Yeah? Yeah. What's the square root of 4? Times 4 already? Times an x? I think we're going to end up with 8x, and what's left behind inside the radicand? 2 root 48x squared in lowest term, simplified, is 8x root 3. I. Ah! No. Relax. Relax. I think the first thing, Brianna, that I'm going to do is I'm going to go, let's write a 2. Because there's a 2 in the front, that's going to drop down. Root 48. Okay, Kira has a good memory. Kira said, hey, Duick, now I know root 48 is root 16, root 3, which it is. X cubed is what times what? No, 3 times 1 is 3. X cubed is what times what? Talk to me, girl. What? Did you hear her? Did you hear? She said, well, Mr. Duick, you said we're supposed to write it as a perfect square times something. X cubed is x squared times x. Isn't that still the root of x cubed? Why did she pick that? Oh, what could we do with that x squared? Brilliant. In fact, that's worth a candy. I thought I'd have to coach you guys a lot longer to get there, but no. I underestimated you. I'm disappointed in you. No. All right. We're going to end up with a 2 in the front. What's the root 16 going to give us? Okay. Who's my soccer players? So in front, Amy, the 2 drops down, yes? 2 drops down. Come on, eraser. 2 drops down. What's the square root of 16? Square root of 16, what? 4. You good, Kurt? What's the square root of 3? Does that simplify? Just drop it down. Hey, what's the square root of x squared? What's the square root of x? Does that simplify? Just drop it down. Let's put it all together. What am I going to have in front of everything? I see a 2, a 4, and an x outside the square roots. See them? See them? See them? 2 times 4 is? Times x is? This is going to be an 8x outside. Root. What's left behind inside the square root? 2 things. 3x. Nice. A little weird at first, but since we have Simi's rule, we're going to be okay. We'll name it after you. J. Okay, I'm not going to panic now. Well, I guess that negative 3x is going to stay in front of everything. Inside the radical, I see a 20, an x to the 5th, and a y to the 7th. I'll deal with them one at a time. 20 is what times what? Root 4, root 5. X to the 5th is what times what? X cubed isn't a perfect square. Yeah, by the way, you could go x cubed, x squared, but I think even better would be, isn't that the biggest perfect square? And I'll put the 1 there just this once so you can see we did take 5. Oh, wait a minute, they're inside a square root, inside a square root. That's terrible, Mr. Duke. Let's rewrite that. Root x to the 4th, root x to the 1. Yep. Yep. Oh, how can I write y to the 7th as something times something? Y to the 4th, y cubed would work, but there's a better one. Y to the 6th, isn't that a perfect square? Let's see. There's a negative 3 and an x in front of everything. Oh, what's the square root of 4? There's going to be a 2 in front of everything. Let's do all the perfect squares first, then let's get the non-perfect squares. So we took care of that guy. What's the square root of x to the 4th? It's going to be an x squared in front of everything. What's the square root of y to the 6th? It's going to be a y cubed in front of everything. And then I'm going to have a root 5, a root x, and a root y. Is that right? I got it all, Amber? Okay, let's multiply the numbers. I got negative 3 times 2. What's that going to be in front? There's going to be a negative 6 in front. How many x's? I got 1 here. I got 2 more. How many x's in front? There's going to be an x cubed. How many y's in front? Y cubed. What's left behind inside the square root? 5xy. 5xy. Am I going to pause here? Let me see. Monday, we'll go backwards. Monday, we'll ask Brody, what if they give us this as an answer? How would we turn it back into one square root? How would we go from 5 root 2 back to root 50? And you can probably, Brody, almost figure out how we're going to do it. Instead of the 5, we'll put it back inside the square root by making it a 25. It's not too bad. But for now, have some homework for you.